Alright, welcome to our third video in this unit. Again, I'm Dr. Prince, and this is the Integrated Math 1 video series. We're going to get to our lesson here in just a bit, but let's start with a warm-up for today. Again, 6 problems. Take some time. Again, try to do some mental math if you can, otherwise you can write it down. Alright, so let's take a look at number 1 here. What function has a constant rate of change? In the lessons, past 2 lessons, we've talked about a constant rate of change, which looks like a straight line, and that is a linear function. A linear function. So that's the type of function there. Quickly estimate these 3 here added together. Again, if you walk into a store and you check out with 3 items, you want to be able to estimate really quickly how much your total should be without pulling out a calculator and adding up all the cents exactly and that kind of thing. So if you look here, we have a little bit over 12, a little bit under half of 4.5, so almost half of almost to 4.5, and then we have 11.5. So if you think about, we could pair these together pretty well. So we have 12 and then a little bit more, and then the 4 and almost half. Together they make, so let's see, 16, and then we compare those to make a half. And so we have 16.5. So pair that half with this one, and you get another whole. So that's 17. Plus the 11 makes 28. So real quickly, we should be able to look at this and kind of say, okay, we got 12 for 16. And 11 is 27, and then these 3 together make up about 1. So again, 28. So a little bit different way to approach it. Either way, we should be able to estimate those. Let's take a look at number 3. 2 to the negative 1 power. I've kind of threw this on there kind of to see if you could kind of take the pattern that we looked at last time and extend that. And let's see what we get. So let's see. Remember the pattern we saw last time was, let's see, 2 to the third is 8, 2 squared is 4, 2 to the first is 2, 2 to the 0. Remember, we're dividing by 2 each time, and so 2 to the 0 we said was 1 by definition. And the beautiful thing about mathematics is that everything works so well together. So even though negative exponents are defined a little bit differently, it all works together. And so if we continue this down to 2 to the negative 1, I wonder what that would be. I think you got it, right? 2, 1, divide by 2 again, and you get 1/2. So that is 2 to the negative 1 power is 1/2. All right, up next 4. What is the function type? What is the function type here? If you remember from our last video, we talked about these types of functions that either grow exponentially or decay exponentially. And this is one where we're talking about decay exponentially. And we'll get into exponential functions later on in other units, but at least be able to recognize the graph that we're talking about here is an exponential function. All right, number 5, 102% of 40. So real quick, 102%. Well, 100% is the value itself, right? So 102% should be just a little bit more than the value itself. So let's think about this here. Remember, a couple ways we can do this, but one way is to take the 2 numbers involved. So really, 102, and then the 40 we can think of just as 4. So if there's any trailing zeros, you can remove those. So just multiply the numbers involved. And so 102 and 4, well, let's see. To multiply by 4, we can actually multiply by 2 twice. So 102 times 2 is 204. Times 2 again is 408. So it's some version of 408. It's either 408 or move the decimal place back to 40.8. Let's see, does that make sense? It does, doesn't it? Because we said it was going to be just over 40. Because if you take it one step further, 4.08 it doesn't make any sense, right? We're talking about number sense. So our answer here is going to be 40.8. The other option there is to take 2% of 40 and then add it to 40 itself. But I really recommend taking those two steps and just doing it in one by multiplying by 1.02 or 102 and then moving the decimal. All right, next we have kind of a challenging problem here. 123 divided by 4. In the last problem, we multiplied by 2 twice in order to multiply by 4. So what do you think we could do here? That's right, we could divide by 2 twice. So 123 divided by 4, we can divide by 2 twice and get the same result. So 123 divided by 2 is 61.5. 61.5. And then divide by 2 again. Let's see, 60 divided by 2 is 30. And then 1.5 divided by 2 is 0.75. So 30.75. So those are just some really good mental math strategies with working with 4, multiplying by 4 and dividing by 4. So with that, let's go ahead and get into our lesson for today. And our goal for today is really to describe everything that we talked about in the last lesson. So we talked about linear functions, piecewise functions, absolute value, exponential functions. Those are all functions. And that's what kind of is common throughout those. But the question now is, what is a function? What makes those a function? So that's our goal for today, is to understand the definition of a function and identify whether a relationship is a function or not. So we're going to get into some examples. We're going to look at some different representations, so points, graphs, tables, all that kind of thing, to see if relationships between two quantities form a function or not. All right, so let's get into it. So first of all, the definition of a function. So here's how we've defined a function. It's a relationship in which every input, so every value that we're putting in, has exactly one output. So we'll talk more about what that looks like, but every input has exactly one output. All right? So in other words, there's no uncertainty with the outputs. There's no uncertainty about what the output is. We can know precisely the one value that is outputted. All right? So we'll introduce some more language that'll make this definition a little more mathematical later on. But for right now, let's just think about it as inputs and outputs. Every input has exactly one output. So let's take some examples. So we've got a set of people, and we want to know what city they live in. So if we ask people, so that person, let's say we ask Jack. If we ask Jack what city he's from, Jack could tell me what city, right? He's only from one city, or whatever city he lives in right now. He only lives in one city. So he could tell me, hey, I live in Murfreesboro, or I live in Laverne. He could tell me that, right? He knows what city he lives in. But what if we took that same group of people and we said, who lives in Smyrna? There could be tons of different people raise their hand. So there's some uncertainty about who lives in Smyrna, because there's not just one output for that input of Smyrna. There's multiple outputs. But yet when we ask Jack where he's from, there's only one answer. There's no uncertainty there. All right, let's try another example. So person being the input, city being the output, that's a function. City being the input, person being the output, that's not a function, because again, there's multiple people that could respond to say that that's their city. All right, remember the example we had a couple lessons ago where we were talking about sunlight and the sunlight over a 24-hour period, right? Well, what if we wanted to know what's the sunlight at a particular time? So sunlight is our input. The output is the time in which it had that much sunlight. Is that a function or not? Well, if you think back to those graphs, there were 2 or if not more times during the day in which the same amount of sunlight was occurring. probably maybe in the morning and then afternoon. The same amount of sunlight was occurring. So if I say, when is the sunlight this much? Well, there could be multiple answers, multiple times in which that occurred. So it's not a function. However, what if we said, what if we reversed it? Sorry, I went out of order here. What if we reversed it and said, at what time, well, at this time, what's the amount of sunlight? So at 3 o'clock, what is the amount of sunlight? Well, there's no choice there. I know because there's only one value that I see there that's happening at that particular time. So input of time, output the amount of sunlight at that time, is a function. All right, let's move on to the last example here. Let's say I give a set of students problems to work on. And let's say I give some of the students the same problem. So just have that as our scenario. If I said, who's got all these sets of numbers of problems, could I tell what student had that problem? Well, for some of those problems, I probably could, because maybe I only gave that problem to one person. However, for those problems that I gave to multiple people, I can't determine that. So because maybe I only gave one problem to multiple students, but because of that one problem, I can't decide what student had that because it had multiple outputs. It's not a function. So I hope that's making. I know it's kind of a strange concept, but every input, every value in the input. So some of these values have one student to go to, but every value in the input has to have exactly one output. So because there might be one problem that doesn't map to one student, it makes it not a function. However, what if I go backwards and I say, what if I list out all the students and I ask them each one at a time, what problem did you have? Could they tell me? Yeah, because they all had a problem, right, to work on. And so it makes that a function. So those are kind of some real-world contexts. We'll get into some more in a bit. Let's turn our attention now to maybe more mathematical representation of this concept. So I have a list of inputs and outputs. Some of you know this to be a table of values. And sometimes you might see like X there and Y there, but I want to keep it as input and output because later in your mathematical career you may have a different input and output than maybe X and Y, but well, we can call them X and Y for now. So if every input has exactly one output, so look at the table real quick. Does every number in the input have exactly one output? Or is there an input that maybe occurs twice and has a different output? Let's see. 3 goes to -1. Is there any uncertainty about what 3 goes to? No. Right? All right, how about 5? 5 goes to 0. Is there any uncertainty about whether 5 goes to 0 or not? Well, down here it says 5 goes to 4. So, because this 5 value occurs twice, meaning an input of 5 has multiple outputs, an input of 5 has 2 outputs. So therefore, this is not a function. This set of points in this table that form a relationship is not a function. So while it is a relationship or a relation, it is not a function because of that. Because every value in the input didn't have exactly one output. Some of them did, but not every input. Okay? So let's take this table and let's put it into a set of points. Same values here. Is this a relation that's a function or not? Because we have a relation no matter what. It's just a question of whether it's a function or not. Well, same thing here, right? We still have this. These are the inputs, these are the outputs. It's just formatted differently. It's the same relationship. So because of the last one not being a function, this one is also not a function because of this 5 value and this 5 value. Okay? So we're not sure if 5 goes to 0 or 5 goes to 4. So because there's some uncertainty there, then it's not a function. Let's look at it in terms of a graph. So this is our x-axis down here, and this is our y-axis here. Does every input have exactly one output? Now, you got to think about too, not every value may be in your input. Like -1, there's no point here at -1. That's not a value in our input. Okay, in our next lesson, we're going to start calling that domain. Okay, so -1 is not part of our input or our domain. A value like 2, though, is, because there's a point here at 2 on the x-axis, right? So at 2, we're down here at -1, 2, 3, 4, 5, 6. So positive 2 is part of our input or our domain. So does every input have exactly one output? So an input of 2 has an output of -6. Is there any question about that? There's not, right? Because there's not another point at 2 that tells me otherwise. Okay, how about 3? 3, I'm at -1. I'm certain about that. There's no question. 4 is not a value in our input, and neither is any values in between. 5 goes to 0. Oh, but wait. 5 also goes to 4. So there's some uncertainty there. What is the output when we put in 5? We don't know, right? Because there's multiple choices. So this part right here at 5, because these 2 points right here are both have an x value of 5, it makes it not a function, just like the table did and just like the set of points did. And then if we go on, 6 doesn't have a value there. 7 is good. 8 is also good because there's only one output. But because 5 kind of messed things up for us, this is not a function. All right? Because of that right there. Okay, so let's kind of switch gears a little bit away from this particular set of points and move on towards a graphical approach with a continuous line. So notice these have arrows. They go infinitely to the left and infinitely to the right because they continue on forever. So every value along the x-axis are part of our domain or our input. But the question is, does every input value along that x value map to exactly one output value or y value? So let's see here. Let's do the blue line first. So we're just looking at the blue line right now. So -1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So let's start at maybe 11 here. So 11, does 11 map to one value? Yes, it'd be right in here, right? There's no uncertainty. 11 goes with -4. 10 goes to -1.5. 9 goes with 0. 8 goes with 1. 7 with 2. 6 with a little bit above 2. 2.5 goes with 5 here, and so on. Every single one of these values goes to exactly one y value. So there's only one output for every single one of these inputs. At no point along here do we question what the output value is. All right? So let's move on to the red line. Okay? Out here at -9. -9 is mapped to 1, 2, 3, 4, 5. So -9 goes with 5. There's no question about that. -8, also 5. Is that okay? Is that okay that they have the same output value? Yes. Yes, it is. Because still, every input has exactly one output. It's okay that they're the same output, but every input has to have one output. Okay, so I think this is 9 here, same thing. 8, same. Well, wait a second. 8 has an output of 5 and -3 here. So which is it? Does it map to 5 or 3? There's a question there, right? Where there's some uncertainty. And so because of that, this whole red continuous line is not a function. So this graph here in red would not indicate a function or represent a function. So I hope that's kind of making some sense here. You may have heard, or you might hear your teacher or somebody else mention the vertical line test. And it's kind of getting at this idea that we're talking about here about looking for more than one output for each input. And what that vertical line test says is if I go across here and with my arm here being the vertical line, if my vertical line as I go left to right here, if it hits the graph more than once, then we got a problem. It's not a function. Okay? So with the blue line, okay, my arm is only hitting the blue line once everywhere along here. Right? But what about the red line? Okay? Here I'm good. Good. Oh, we got a problem, right? Because my vertical line here that I'm making hits the function more than once. And that's just a kind of a good indication of it not being a function. So it's kind of a good test that you can run. But at the end of the day, you've got to remember that a function is a relation that has, for every input, has exactly one output. All right? So that was our goal for today, was to not only define a function, but I'd be able to identify a function. All right, so let's do a quick activity, and then we'll be done for today. So this is a card sort, and I'm going to kind of give you a second to kind of sort these just on your own into two groups, not a function and function. And I'm going to move these around so you can see each one. And then we'll kind of go through it together. So just on your own, see what you can do. Alright, so let's kind of go through these. Let's start with the contexts. It says, in a class of 9th graders, the relationship between shoe size and height. So shoe size is the input and height is the output. So do you imagine if I said, what's your shoe size? And they gave me their height. Do you think I would be able to, do you think it would ever occur that I would ask for shoe size and two people with the same shoe size have the same height? Or different heights? What do you think? If two people with the same shoe size have different heights, then that would indicate this is not a function. So if that's possible, then this is not a function. And I believe it is, right? Obviously you can have the same shoe size and have different height. So this is going to be not a function. Okay, let's look at the other context. A class of 9th graders, the relationship between student and height. So my input is student, the output is height. Can a student have more than one height? That wouldn't happen, right? So that is a function because every student has one height. Okay, let's move on. Let's compare these two graphs right here. These are what we call step functions. Remember that from a couple weeks or from a couple of sessions ago. So these look like step functions at least. All right, so this one, does it pass that vertical line test? Does every input have exactly one output? Well, let's look at negative, 1, for example. So I have an output here, 0, but I also have an output down here. Because they overlap, this is not a function. Do you see how these lines, so this line here, and I can draw it on here as well. So if I draw that vertical line down, it's going to hit both of these lines because they overlap like that. Whereas this one, they're all separated, kind of like the step functions we did a couple sessions ago. And so this one's not a function, but this one is. So this one's not a function, this one is. All right, let's move on. Y equals absolute value of x. You probably remember that graph from last session. The graph looks like a V. Let's do a rough sketch here real quick. A V, does every input have exactly one output? Yes. So therefore it's a function. Okay. Let's do these two graphs here. Now while this is not a continuous function, this is what we call a discrete function, meaning it's got a set of points and not a solid continuous line. So does every input have exactly one output though? Yes. So this one is a function. How about this one though? Does an input of 4, for example, have one output or multiple outputs? Well, an input of 4 here has multiple outputs, and so therefore it's not a function. So this one will not pass the vertical line test, therefore it's not a function. Every input does not have exactly one output. And then lastly, plus or minus the square root of x. Let's think about this more maybe algebraically. So if we input a value, let's see if we get one output out, or is it possible that we might get multiple outputs out? So let's see. Let's put in 4 for x and see what we get for y. Well, if we put in 4 for x here, square root of 4 is 2, and then this plus or minus means you're going to end up with both plus and minus of that value. So 4 as our input resulted in plus 2 and minus 2. So because that input had multiple outputs, it is not a function. All right. So hopefully that kind of gives you an idea of what a function is, and then how can we identify whether it's a function or not. And that was our goal for today, was to figure that out. Now in the next lesson, we're going to continue to talk about this idea of a function, but we're going to maybe include some more sophisticated language. So instead of saying input, we're actually going to start using the word domain, as I mentioned earlier. And then instead of using the word output, we're going to use the word range. That's the set of numbers that are outputted from our function. Back when I was your age, the way that I remembered these two is domain. The last 2 letters in domain is N. Like it or not, that's how I remembered it back in the day. So if that works for you, great. To remember that domain is the input into our function. All right? So hopefully that gives you a good overview of what a function is and how to identify it. And we'll look forward to seeing you in the next video.